finding square roots and cubed roots. So if we take our composite numbers that have perfect square or perfect cubes for factors, we go back to the times table, and we've got 2 times 2 is 2 squared, or 2 times 2 is 4. So if 4 was under the square root symbol, and the index was 2, we'd be looking for a factor to be repeated twice. So we have our root or radical symbol, we have our index, and then the number under the root symbol or under the radical symbol is called the radicand. And so whenever I have a perfect square in my radicand, the square root undoes the square. 2 to the second power under the radical, index is 2, looking for a factor to show up twice, and the square root of 2 squared would just be 2. Same thing for another factor, maybe 7 squared. So under my root square symbol, I would have 7 times 7, 49. If I see 49, square root of 49, I see that as 7 squared. The square root of 7 squared undoes, the root undoes the square, and I'm left with just 7. So anytime I have a factor times itself, 5 times 5, 25, well, that's 5 squared, and the square root of 5 squared is just 5, and that 5 comes outside the radical symbol. In the same way that we had perfect squares, we also had perfect cubes. We take square roots, well, we can also take cube roots by changing the index. Now, ordinarily with square roots, we don't write the index of 2. But when you're first learning, it's probably a good idea. It lets you know the factor needs to show up twice to come out from under the radical. If we switch over to cube roots, well, 2 times a second 2 times a third 2 is 8. If I saw the square root of, the cube root of 8, it would be a 2 times a second 2 times a third 2. And that's 2 times 2 times 2 again. That's 2 to the third power. Third root undoes third power. The root is the inverse of the exponent. And a 2 comes outside. Same would go for the 5s. 5 times a second 5 is 25. And 5 25s, that's 5 quarters, $1.25 or 125. And so we look at this as 5 to the third power, or 5 cubed. Cube root of 5 cubed, just 5.